All right. Hello and welcome, everybody. Welcome to the Student Zone at dotnet Conf. We're so excited that you're joining us here today. We've got a lot of really fun sessions to get you kickstarted with dotnet Conf. And then, once dotnet Conf starts, you're going to actually get to see a lot of awesome sessions happening then as well. So Kinfei and myself, we're here to talk to you about AI. You may have heard a thing or two about that. And so we're super excited to help you get started with AI and hopefully show you something useful here that's going to help you with your studies. So we're going to be building our own course assistant using AI. But before we do, I just want to take some time to introduce ourselves here. So I am Luis Quintanilla, and I am a senior product manager working in .NET and focusing on the areas of AI, right? So that's going to encompass a lot of different products here. And just at the end of the day, is ensuring that, developers are really productive building these types of AI applications using .NET. I'm based out of the New York City area. And yeah, whenever I'm not coding, I'm probably hiking one of the trails and just having fun. So Kinfei, would you like to introduce yourself?
Yeah. Hi, everyone. My name is Kinfei. I'm Microsoft Cloud Advocate. I focus on AI and data. This time, I'm very happy to join the Student Zone. I love .NET and use .NET to do more applications. This session, I will introduce some AI solutions using Azure OpenAI and Semantic Kernel to create the easy applications to chat with some machine learning knowledge.
Awesome. All right. Let me just jump right in. So a quick overview of some agenda items and things that we're going to be going over today. Introduction, we kind of got through that already. So it's nice to check things off. Then we're going to jump into prerequisites, just some things that you should be aware of or things that you might need to help get you started as you go and try to build this solution yourself. We're going to do a really quick primer on AI, not go too deep because actually we're going to be talking about a lot of the concepts and showing them off as part of the demo. We're going to introduce what we're going to be building here, how we're going to go about building this course assistant using AI. And then, last but not least, which is probably what you're here for, you're going to get to see some code, you're going to get to see a demo and see how tangible this is and how easy it is to get started. So with that, some prerequisites and things that you're going to need to get started. First and foremost, a GitHub account, right? And the reason for this is number one, because you're going to be able to access some of the resources that we're going to be showing you here today. But most importantly, as you're going to see when it comes to setting up your environment with GitHub Codespaces, which we'll talk about a little bit later, it becomes super easy for you to get started with very little to no setup on your end. And then one of the other things that you're going to need is access to whether that's Azure AI, Azure OpenAI Service, or OpenAI in general. You're going to need to have access to that in order to tap into the models that we're going to be using here today. So really quickly, let's just start off with some terminology. You may have heard different sort of concepts out there being thrown out like AI, machine learning, generative AI, LLMs. All these terms are just, flying around. And so you might be, wondering like, okay, well, what's the difference? Are they the same thing? What's going on here? And so let's start off with AI. And AI is sort of the big umbrella that all of this really sits under, right? And you can kind of think of AI as this, way these agents or these systems, right, that are performing actions that humans would normally perform. And so to give you a pretty good example of this, let's think about your spam filter or maybe, filtering email that's coming into your inbox into separate folders. Now, typically, the way that usually works is you go into your email client of choice, like Outlook or any email client of choice, and you start to set up some rules. You say, well, if this, for example, if this email is coming from a particular sender or if it has a subject, this particular subject, I want you to organize it and categorize it into this folder or do something with it. And now, once you set up that rule and as to how to categorize your email client automatically handles that organization and categorization of those emails for you. Right? And so again, that's something that you would normally manually do, but now it's being automated by this, by your email client or by this system. And so in a sense, that's AI, right? And so in that case, though, you were the one for each of the actions that you wanted to take place. You are defining what the rules are, right? And so that works really well for these sort of smaller scale scenarios, or if you only have a few rules or a few things that you want to define, right? But as you start to sort of scale out and like just you have all these different things that you need to consider, and the rules, those things that you're using, those rules that you're using to make those selections start to get a little bit more complex. That's when sort of this rules-based type of systems, right, start to hit some of their limitations. And that's sort of where machine learning comes in. So with machine learning, instead of you setting the rules, right, you use data, it could be historical data, right? And then you apply algorithms to that data in order to learn what the patterns and what those rules are. So instead of you defining the rule, it's using data and algorithms are being used here to learn what those rules are. And then once you've trained a model, which I'm going to talk about a little bit later, at that point, you just then use that model on new data to perform the task that you trained this model to do. A layer below that is deep learning. And so deep learning is just different. It's still machine learning. You're still using data. You're still using algorithms, but you're using a specific set of algorithm known as a neural network. Okay. And then the last layer of generative AI, that's typically a set of deep learning algorithms, typically using transformer-based architectures. And what these generative AI models do is they allow you to generate or create new content. So we're going to be showing a few examples here, and you're going to see it as part of our demo. But it could be things like given a prompt or a description, it can generate an image, or it can create a summary of some piece of text for you, can translate text, right? So it's generating new content using these generative AI models. The ones that are text-based are typically known as large language models, right, or LLMs. And so that's part of this generative AI sort of umbrella here. So with some terminology out of the way, you've been hearing me say model a whole lot. And so what exactly is a model? Well, you can think of a model as sort of this, opaque box here, right? That, again, we took some algorithms, we took some data, we mixed them around. And once we learned what the patterns in our data were, we end up with a model, which represents the patterns, again, that the data that I have exhibits, right? And so I can train a model for a variety of tasks. And once a model has been trained, all you do is you pass it in data, right? And this could be text, this could be images, this could be audio. You pass it to your model. Your model uses the patterns that it's learned and applies the algorithms, right, that it uses to learn that data. It runs it through the model, and then out comes some other set of data, right? And that could be text, that could be images, that could be audio, right? Whatever it is that you train your model to do, that's exactly what the inputs are going to be coming in. The model's going to process them, and then it's going to output them to whatever the expected outputs are. And so just to give you a little bit more concrete, as we're talking about OpenAI set of models, right? We have a variety of them, and you can see them sort of listed here. And so the GPT portion of these models, they typically accept text, and then they output text. And then things that you can do with them are things like, you can, again, generate summaries, you can sort of summarize text, you can answer questions, you can translate text. There's a lot of really, so if the mapping is from text to text, chances are that a GPT-based model could handle those workloads. And then embeddings, we're going to talk a little bit about that later. But you can think of embeddings as a way to represent unstructured data like text, like images, right, as a float array. You're going to see a little bit more as to where this becomes useful. But for right now, let's just focus on the fact that embeddings are models themselves as well. And they take in text inputs and they generate an embedding vector, which it looks like a float array. Okay. You have DALL-E, which, again, given a prompt or a description, it generates an image, right? And so you have models like Whisper, which they take an audio. You can think of a podcast, or maybe if you're in school and you record your lectures, right, your audio lectures, you can run that through Whisper and pass the audio as input. And what's going to come out is going to be text, right? So the transcript of that audio, you can sort of process and generate text using the Whisper model. Okay, so Let's get into the fun stuff of what we're actually going to be building during this session. So one of the things many moons ago, I too was in school, believe it or not, and one of the things that I think would have been super helpful if it was around, and AI was at the stage that it is today, it would have been really nice if I had a sort of assistant that can help me study, right? So usually, if you want to study, or if you have questions about the course material, or maybe you didn't really understand something, right? Typically, you might go to maybe a course assistant. You might maybe even go to one of your peers. Like, you might want to find some way of augmenting or clarifying some of the knowledge that has been captured throughout your courses. Right? Unfortunately, back then, back in my day, that wasn't a thing. Or if there was something like that, it was like really hard and expensive to set up. But with AI and some of the generative AI capabilities that models like GPT, right, provide you, it's getting easier to do that. And models like Whisper and all that, right, it's becoming a lot easier. And so as we set out to build this course assistant using AI, at the end of the day, we tried to keep it super simple, right? And so really the main application here is this course assistant that you see in the middle. And this course assistant is a .NET console application, right? And all that this application does, as you'll see in a minute, is it takes in your user input. It uses some of the models, right? That are there, right? So we're going to be using some of the embedding models. We're going to be using some of the ChatGPT set of models, or the GPT set of models, and that's going to drive the intelligence or the AI behind of our application, right? And we're also going to be using data to help our models answer questions and help us with sort of parsing through the content that's coming from various sources. So in this case, we have some lecture notes that are hosted on GitHub. And we also have transcripts from videos, right? So you can imagine that in your class, your lectures are recorded. And so you have transcripts that are available to you, right? And so all of this data, we're going to parse through it, and we're going to put this inside of a data store, right? We want to make sure that we get this into a data store so that later on, the models can actually use that data to help us answer questions, again, that are relevant to the courses and the topics that were being covered in our course. Right. A little bit of a side note here, but if you, for example, in this case, we already had the transcript, so YouTube already provides transcript for you. So that was, a relatively easy task. But if you recall earlier, I mentioned how there are models like Whisper that can take audio and convert it into text. So you might imagine that, for example, maybe your lectures are not on YouTube and they might be somewhere else, right? And so in those cases, you might be able to use models like Whisper to help you generate these transcripts. And a lot of this would pretty much look the same. Okay, so we have the data store, and that's what's going to be holding the content for our notes and for our transcripts. The data store itself, it's actually a vector store, which we're going to talk a little bit about, again, what embeddings and vectors are a little bit later on. But it is a vector store, right? We're using the GPT set of models. And the thing that's actually bringing or helping you compose all of these different pieces of your AI application is Semantic Kernel, right? And so that's really what's driving a lot of these interactions. And typically the workflow is whenever a user asks a question to the .NET Course Assistant application, it first goes out and retrieves relevant data to the query, right? So that's the retrieve portion that you're seeing here. Once it retrieves the relevant data, it augments the information that's being passed into the model. So not only am I asking my question to the model, but I'm also giving it the data that was retrieved, right? And so once I have the data retrieved plus my query, the model uses that information to generate an answer, and that's what gets returned back to the user. And so this pattern is typically known as retrieval augmented generation, right? Because of the retrieve, augment, and generate components of this pattern. So really quickly, before we jump into the demo, I just wanted to do a quick overview of what Semantic Kernel is. So Semantic Kernel it's an open source SDK, which you can use in .NET. And again, one of the things that it does is there's tons of different, vector stores, models, like there's all of these different sort of components that are out there that can help you build applications. And it's up to you, depending on your scenario, which ones you're going to choose, right? However, one of the challenges with that is that now you have to go learn an API for each of those providers, right? And so what Semantic Kernel tries to do is it tries to provide that abstraction layer, right? That's going to make it simpler. So you learn the Semantic Kernel set of APIs, and then you're going to basically simplify that integration piece of getting the AI components into your application. It simplifies that integration, right, into both, whether it's a new application, existing application. Again, we can use it because you can use this in .NET, right? Really, it doesn't really matter as long as you're using a .NET application. And so you can see to the side here a brief illustration of what Semantic Kernel is doing. So using these connectors, right, it's able to tap into the components like the models, like the OpenAI models I was just talking about. It can tap into memory or the data stores and vector stores that I was just talking to. Now, we're not really going to get to it, a whole lot in this talk, though there is some components that we're going to be showing here, but also plugins, right? And plugins, they're a way for you to interact with external systems and carry out sort of tasks that the model was not originally able or trained to perform, right? So these plugins enable the model to carry out additional activities beyond what it was trained to do. Okay. So with that, I think it's time. Kenfei, would you say should just jump into the code?
Yeah. Yes.
Awesome. Real quick, before we sort of jump into the code, one of the things that I want to call out here is that by the time that you're watching this session, chances are that Semantic Kernel is currently in beta state, so the code is moving quite fast. And so it may be possible that some of the things that we're showing you here may change between now and then. But we're going to make sure here that that this is up to date and that you get the latest bits, and so you're off to the races here and can get going right away. So with that in mind, Kenfei, you want to take it away?
Yes. Hi everyone. I will introduce this sample. The first thing, maybe the data is very important. I know, just like Louis said, we need to prepare some data from YouTube transcription and some logs. And this time, maybe our first step is import the semantic kernel in the notebook. .NET Interactive notebook is very good for us to do some machine learning jobs and some write some prototype. And at this time, we will have the .NET Interactive notebook here. If you open the GitHub repo, you can use you can choose the code and use the code space to do this workshop. I think code space is very good for you to finish this sample. When you open the code space, you can see the environment all set here. And then we can see that the first thing is the import semantic kernel library. The first library is the semantic kernel library. The second library is the some memory. This here I use the vector DB is the Cogent. Cogent is the vector DB for you to do some embedding jobs to some large language model. This time, if you finish to import semantic kernel, you can set some using some library, some semantic kernel library, and some relative about our system library here. And then we need to use the kernel to set the runtime. What is the kernel? The kernel is from semantic kernel. You can configure multiple settings that are necessary to run both native and semantic functions. You can set some OpenAI OpenAI services combined with semantic kernel and some template engine and log and plugin work together. Here you can see that we need to set the Azure OpenAI endpoint key and embedding deployment and track deployment and some Cogent hosts here.
Yeah, so these are running .NET code, right? These notebooks.
Yeah. Why the notebook is low? It's
okay.
The low. Yeah.
Sorry, what were these called? Are these polyglot? Did you say?
Plugin here.
Okay. Yeah. Okay. Yeah, so I just wanted to make sure that I understood that part where you were launching into code spaces. You're running this IPYNB data prep IPYNB file.
IPYB file, yeah,
Yep.
here.
But this is running .NET code, right?
Yeah, .NET code is,
Okay,
yes,
got
this
it.
is a .NET code, yeah.
Okay, awesome. Yeah. So so if you wanted to sort of do something similar, then I think what folks might want to check out here is the Polyglot Notebooks extension, right, inside of Visual Studio, if they want to run these types of notebooks.
Yeah, this is the notebook is in the Visual Studio Code, yeah.
Gotcha. Okay. And then, but did you have to set anything up, or was that automatically set up for you with the dev container?
Container.
Yeah. Okay. Got it. Okay. So here is where inside of your definition, this dev container JSON file, you said, I want the .NET Interactive VS Code extension. And so that's how you're able to sort of view and run these notebook files, Polyglot notebooks files, right?
Yeah.
Okay, cool. And so if I understand correctly, if we go back to the kernel, so it sounds to me like the kernel, that is kind of like the starting point for all of this, right? Is that sort of like the main engine that's driving Semantic Kernel, or did I understand that wrong as far as to what the kernel is?
Yes, the kernel is the main engine here, yeah.
Gotcha. Okay. And so with Azure Chat Completion Service, that's one of the things that you mentioned was one of the connectors, right? So
Yes.
okay. And then in this case, this Azure Chat Completion, it's essentially setting up the chat completion service for Azure OpenAI. Is that correct?
Yeah. This is for Azure OpenAI. Yeah.
Right. Yeah. With the connectors, right? Like, so with the connectors, you're able to essentially, in this case, it's specific to Azure. But if you wanted to use some other connector, you would just, this is the place where you would replace that and change it, right?
Yes. I can change this. Yes.
Yeah, got it. Okay, nice. Okay, awesome. And so I interrupted you here, but we were talking about plugins, and I think you started showing this skprompt.txt file. So do you want to kind of take it from there and just tell us a little bit more about what this skprompt, first of all, what the plugins, what are the components of the plugin, and then talk a little bit more about this skprompt file here?
Yeah. skprompt.
Yep. And so the plugins, there's a plugin directory here, right? If I'm seeing correctly. And so right now you're currently in the answer plugin.
Right? No. Sorry, here.
Got it. Okay. Okay, so you're in the notes plugin now, in this file plugin and specifically notes. Okay, and so I'm seeing some patterns here. So I'm seeing that there's a config.json and there's this skprompt.txt file. So what is the purpose of this skprompt.txt file?
Actual prompt is here. And here.
Got it. Yeah. Okay.
This is the two prompt. The nodes for the nodes. I think this is the full content to understanding and to write some summarize here. The transcript because the transcript data is very interesting. Is it can get the intro program and some knowledge here or set a different AI and ML. So I use two methods to write the prompt. The first the nodes prompt is for the full content. The second prompt is the focus some knowledge and the knowledge title and some contents to separate some contents here.
I see. Okay, and so this is, if we take a step back here, going back to these text files that you just showed. So that's the raw data, right? The way you just showed us, the transcripts, the for example, introduction, the history of ML and techniques of ML. That's the raw data, right?
Yeah.
Okay. So the prompt, right? This prompt file that we have here, this is what's being sent over to the model as input. Is that correct?
Yeah.
Okay, got it. And so the prompt is essentially just, that's what's going to be telling the model what it should do. Is that Am I understanding that correctly?
Yeah, yes.
Okay, got it. Okay, and so when you're building these plugins, you have this skprompt.txt file. And so that's what's defining the prompt that's going to be provided as input into the model. And in this case, for example, for transcripts or for notes, you're just basically saying, this is how I want you to format my data, given some raw, text, formatted this way, and then that's kind of what we're instructing and providing guidance to the model as to what it needs to do when it generates the outputs. Is that correct?
Yeah.
Okay, yeah, so you're getting the input raw text. The prompt is sort of guiding the model to generate some output. The output that gets generated is some JSON format, right? And then that's what you're then putting into these vector DBs. Into the vector DB in this case. Okay, all right. So let's go from sort of there. Okay, so now we were looking at, I think we're up at the plugin section. So maybe now that we have a better sense of, what are the plugins, what are the components to it, what are they doing, or at least the ones that we saw here for transcripts and notes. Let's go back to the plugins section here and just let's keep going from there. Yeah, so I think that this is where we left off, right? So here you're bringing in the files from that plugin directory that we just saw. And then in this case, this is specifically the plugins we're looking at are the file and the answer plugin, right?
Yeah.
Okay, got it. Okay. And then so what happens next? Once we've sort of imported these plugins, we know what they're supposed to do. What happens next?
Input your plugin and the last is the here because we have some files and transcript files, and to run the file and read and finish the runs async file plugin. Yeah, here.
Okay, right. And so this is going to generate, if we can expand, can you go to the submission? Scroll up a little bit here.
Yes.
Can we take a look at what that's, what one of, like any of those submission, that KB list, one of the elements? So let's scroll down just a little bit to the next cell. Scroll down to the next cell. Keep going, the next cell. Okay, right there. So if you were to expand, you see how there's a little drop down here? What do these submission items look like? Okay. And so these are objects. So this is what the JSON that you said, okay, so it's taking my raw transcript, my raw notes, and now it's converting them to this JSON format, these objects, KB objects. This is what that looks like, right?
Yes.
Okay, got it. Okay. So this is the thing that now was output by the model. So here we're seeing that now it's using this memory. It's saying with text embedding generation. So this is another connector that we're seeing here, and specifically for generating text embeddings.
Yes.
And then the with quadrant memory store, that also is another connector. And so this is what is essentially saying, I'm going to be using this connector to generate text embeddings, and I'm going to be using this quadrant memory store as the vector store where I'm going to be storing the data that we just processed above. Okay, so that's how this is set up. So I kind of see how the connectors are playing a role here. But really quickly, if we take a bit of a step back, these embeddings, the embeddings themselves, they're just a flow array of numbers, right? And so they're helping you here be able to determine what content is going to be relevant when you search this collection, right?
Okay.
Yeah.
Yes.
Okay, got it. Okay, so you've set up now the memory store, you've imported your plugins, you've processed your data, and so what's next? What are we looking at here in this cell?
Save the data here, and the last is the testing.
Okay, got it. Okay, and so when we're calling this search async, if we go up just a little bit to that cell in the search async, what are the things that we're passing to it? If we scroll up just a little bit.
Yeah, yes, I use the answer plugin to summarize because it get the some vector to do this. So I need to summarize from my answer plugin here.
I see. Okay, so this is yet another plugin, and this is yet another prompt. Okay, and that's what's instructing the model. But in the search async, really quickly, if we go just above this, okay, yeah, perfect. This is a good example here. So when you're calling search async, you're telling it the name of the memory collection. If you scroll up just a little bit, yeah,
Yes.
and then you're okay. So if we stay there, sorry, let's go down a little bit. Yeah, right here. So you're giving it the collection name, right, which is that KB collection. And you're also giving it your queries. So can you tell me the difference between AI and ML? And you're telling it to limit one, give you the latest or most relevant result. And then you want the minimum relevant score to be 8. So you want to be the stuff that's closest from the content that you sort of saved into your database. You want to be able to use that data to help you answer the question here. Can you tell me the difference between ML and AI? Is that correct?
Yeah.
Okay, got it. And so in the next section here, what you're doing is you're going through each of the search results and summarizing, basically providing sort of your question and then providing a summary of the content to generate this response right here, right?
Yes.
Okay, got it. Yeah, I mean that seems pretty spot on here. And so to do a quick recap of what we went over here, you in this data prep notebook file, you're running inside of code spaces. You're using polyglot notebooks to run this code interactively, this .NET code interactively. You set up Semantic Kernel to use sort of the embedding models, right? And have also set up the chat completions. You created some plugins, or you use some plugins here in this case to help you process the data. You save the data into a vector store, into Quadrant Vector Store, right? So using the embedding models, you generate the embedding, save that to a vector store, and then you tested it to make sure that when you asked the question, you were able to retrieve relevant results and display an answer here to help you answer that question based on your data, right?
Yeah. Yes.
Okay, got it. All right, awesome. So, all right, so it seems like this is part of the way there, but it doesn't seem like this is the whole solution. So once you've gone through the process of getting your data, processing it, saving it into some data store of some sort, what's next?
Next is I will show the plugin. No. I will show the console applications here and tell the student how to move your application and how to create your application to create the new console projects is here and create a .NET console projects like here to move some code in the notebooks just like at the Semantic Kernel library and Cogent beta library here, package here, and another is to move the plugin here. This is some summer answer plugin. Here is important, and another is to set write some code here to set the environment and some embedding code here. Yeah.
See, and so if we scroll up to the top of this, let's go to the beginning where we're configuring Semantic Kernel and everything.
Yeah. Yes.
Yeah, let's scroll up to the top here. And so as I'm looking here, a lot of this already seems familiar. So we are, again, to your point, we are getting the environment variables, right? So that seems very similar to what we were doing in the notebook. And then, okay, so I'm familiar with the kernel. That looks familiar here. And I can see, again, we're using this Azure Chat Completion Service, but it seems like that's we're also using the text embedding generation. Okay, right, and using the same. Okay, so basically, we're using a lot of the same stuff here that we use in notebooks in terms of connectors for Semantic Kernel. Okay, so once you've configured Semantic Kernel, you configure your connectors. What's next in this application?
Connector is finished here and do some console wide is AI assistant. Yeah. you write the while loop because you have many questions to ask. So I put the put some here to summarize here.
Mm-hmm. Okay, so this looks, so I'm doing the search async, I'm doing the same thing, except in this case, instead of hard coding the question like we did last time, we're just, passing it in based on the user input, right? But then for the most part, say search async here looks very similar to what we had in a notebook in those tests that we ran. Okay.
Yes.
Mm-hmm. Okay. Right. And then for the answer, it's just, again, you just run the text completion piece and pass it in the relevant data, right? That summary that we generate.
Yes.
Okay. So what does this look like when you run it?
Wait.
Okay, I see. So once it got started, you asked it, what is machine learning? Okay. Course in classical machine learning is designed for beginners. So this is giving us, so again, this is pulling the data from those transcripts and those course notes that we looked at earlier, right?
Yes.
I see. Okay, well, what if I asked it something about, I don't know, let's see. Let's ask it something that happened most recently. Let's see. Let's see. Let's ask it about, I don't know, what the weather is in Seattle.
What is what?
Yeah, what is the weather in Seattle? Okay.
No, because this is just search in the Cogent DB.
Right. So there's no answer. Right. So I think, yeah, and this is exactly kind of what I wanted to show, right? Which is, in this case, you told it you wanted to ask questions about ML and AI, but more importantly,
Yes.
you wanted to restrict it to only use the data that's in your database, right?
Yes.
And so now that you told it, like, what's the weather like in Seattle? Well, for one, it doesn't really know what the weather is because, it's not sentient. It can't go out. First of all, it's not in Seattle or anything like that. Maybe the servers are, but so it can't just go outside and tell you the weather or even check the weather, right? A, because it's not part of the database, and B, because it's not connected to some system that can help it learn what the weather is. And so this is what you would expect here because you don't have access to this data, right?
Yeah, but
and so
if you want to ask some question, I can set another things in semantic kernel. It can give you another answer. Just set the weather plugin here and will detect what your answer belong. It will give you the give you the weather answers. Yeah.
I see. Okay. Yeah, exactly. So if I understand, just to summarize here, you're saying that if I did want to have access to the weather, right, there's some, I would call out to some external system and I would go through the same process of building a plugin here to go out and fetch the weather. And then this assistant could help answer that question of what is the weather in Seattle.
Okay.
Right. Yeah. Okay. Got it. Okay. Awesome. So this is looking really good. Thank you Kinfei, for showing this. And yeah, so I would definitely encourage folks to try out the solution, go play with the code, go try to make it your own, even try importing your own sort of data and play around with it, see what you get. And, when you're acing those tests, then yeah, we're happy to have helped you with that.
Okay.
Let's just do a quick recap here before we sort of close out here. But let's go over again what we built. So again, we built this .NET, this course assistant application. It's a .NET Core console app. It's using Semantic Kernel to orchestrate this assistant that, given a set of notes and transcripts that have been processed and stored in a vector store, like Quadrant. Again, for the vector stores, you could also use others like Azure Cognitive Search. You could use Milvus and many other sort of vector stores for this, Cosmos DB as well. But we're storing this into a vector store. You are using that data to then provide information to the model that's going to help it answer the user questions. And then the model's then going to generate the response that then gets returned back to the user, like we saw in the console application here. In terms of resources, you can check out the code samples. The link is available there. You can check out the Semantic Kernel documentation, the Azure OpenAI Service documentation, and then in this .NET AI resources, it provides a list of items that you can go ahead and you can check out and just learn a little bit more about the patterns. You can check out different sort of solutions that are out there, right? Let me just kind of pull this up here real quick just to kind of show you some of the resources that we have available there. Let's bring this over. Yeah, so it's going to provide an introduction. This is a really nice blog post that was put together that's going to help you get introduced into the retrieval augmented generation pattern. There's these plugins that sort of ChatGPT has, and this is a sample that shows you how to build one of those. We have a few sort of AI applications that are available here that you can take a look at. If you're getting started with these notebooks, you can check out the OpenAI Cookbook in .NET. So tons and tons of content that you can sort of go through and take a look at on your own time. Now, this is just one of the first few sessions on AI. So let me just kind of bring my slides back here. Can I bring the slides back? So there's a ton of sessions specifically focused on AI happening at .NET Conf. We have, for example, kicking off .NET Loves AI. We have folks like John Maeda and Scott Hanselman that are going to be talking about just this whole AI landscape. Yours truly and Maria Nagaga, we're going to be discussing how you can build intelligent apps with .NET and Azure and kind of walk you through that process. Scott Hunter's going to be talking about how to scale these types of applications when you're working in Azure. Aaron Powell is going to do a dive into what generative AI is and how as a .NET developer, you can get started with these solutions. Kinfei, we're going to see a lot more of Kinfei, where he's going to show us how to take something similar to what we've built here, but how can we actually build our own Copilot? If you've been using Copilot inside of Visual Studio and Visual Studio Code, Kinfei is going to show you how you can build your own, right? And then, yeah. Would you like to say a little bit more about that session, Kinfei?
Yeah. I think many people to use GitHub Copilot, but I think this time we can use Visual Studio Copilot to run by yourself. This is very cool. Sessions, welcome to my session. I hope you can join my session. Yeah.
Yeah. No, I mean, I know I'll definitely be there, and so I encourage you guys to be there as well. And then last but not least, if you're building for teams, right, meaning that you want to embed these sort of Copilot assistants, AI assistants, right, and you want to do so inside of teams, Aika and John, they're going to kind of walk you through how you can use the toolkit as well as the AI set of libraries in .NET for teams that can help you get started there. With that, there's one last thing I kind of want to show you here, which is this is just one of the many sessions that are going to be happening at the Student Zone at .NET Conf. And so I encourage you to check out this link here, aka.ms/netconf23/student repo. That's going to have all the code from this session, as well as all the other student sessions that are going to be happening, the Student Zone sessions that are happening. Now we've been talking .NET and focusing on .NET, but if you're new to .NET or just in general, you want to get certified in sort of C# and the foundations of C#, make sure to check out this free certification here, aka.ms/C# certification. There is a bunch of .NET beginner videos to help you get started. Now here we just dove right in. We touched briefly on some of the concepts, but these .NET beginner videos are not only going to help you get started with generative AI, but really a lot of the sort of tools and services and things that we have in the .NET ecosystem to help you get started, building AI applications in .NET. And then last but not least, again, the student zone, these are just a few set of sessions, but again, the broader .NET Conf, make sure to check out all the students zone sessions at .NET Conf, as well as the rest of the sessions. Now, AI is just a part of what's going to be happening at .NET Conf, but you're going to also see a lot of sort of sessions on web development, IoT, all things related web, right? So you're going to see a lot of things at .NET Conf that are super exciting. So whatever it is that you're interested in, you can build it with .NET, and you can check out the latest and greatest over at .NET Conf. So with that, we're going to kind of close out this session. Kinfei, is there anything else that you wanted to add here?
Yeah, I think we can. I hope you to join the .NET conference to see you in the .NET conference. This is the .NET party because we way more release, more samples, more sessions there. If you want to learn the .NET, I think this is very good conference here there. Yeah.
Yeah, no, I'm excited. I'm thrilled. I'm excited, especially for AI, but just everything that we're coming out with in .NET 8 and the stuff that we're announcing. So make sure to tune in. Make sure to join us. Kinfei, thank you so much for being here with us, and thank you all for watching. And we'll catch you next time. See you at .NET Conf.
Okay. See you. Yeah.